Hey everyone, welcome back. Today we have kind of a bonus video because it's a topic that I wasn't originally planning on including in my video series, but I think it's a topic that might be interesting and possibly useful for us to know about, which is modular programming. Now when I make my games and create my programs, I want to make them in such a way that they're going to be easy to create and easy to modify and easy to maintain, and also easy to troubleshoot. So the way I plan to do that is by using modular programming, which means to create my programs in small pieces that can be tested independently. And I have some information that I'll share with you that I found on the internet that describes what modular programming is. So this is a definition from Wikipedia, which says, modular programming is a software design technique that emphasizes separating the functionality of a program into independent, interchangeable modules, such that each contains everything necessary to execute only one aspect of the desired functionality. And then it goes on to describe the benefits of modular programming, which says, modular programming helps develop programs that are much easier to read, since they can be enabled as user-defined functions. A program that carries multiple functions is easier to follow, whereas a program that does not have a function is much harder to follow. And by functions here, they're referring to modules or subroutines. And then I found this excerpt from a book called The Spectrum Programmer by SMG. And on page 85, it states, "It is a good idea to form parts of a program into subroutine, even if each part is only used once. The reason for this is that programs that use subroutines are easier to understand, easier to find mistakes in, and easier to modify." So for these reasons, I think it's a good idea to use modular programming so we can build our program in small parts and they can be tested in small parts, and it will make, I think, creation and troubleshooting and maintenance a lot easier. So I'm going to share with you a kind of a method that I've come up with just by experimentation that I think would be useful for creating modular programs. So I've come up with a template in regular Sinclair BASIC that I think I'm going to try using for my basic programs. And today we're just using regular Sinclair BASIC, not Next BASIC or any other programming language today. So if you want to follow along with me, you can go ahead and use an actual Sinclair Spectrum computer if you like, or even the ZX Spectrum Next computer, or in my case I'll be using an emulator, which is the ZX Spin emulator that we installed in a previous video. So if this sounds interesting to you, stick around and we'll take a look at it right now. Alright, so I've got the ZX Spin emulator loaded up now and ready to go. So the first thing I want to do in starting to create this template is to enter a basic program with a line that's going to just record what the name of the program is. So let's enter line 10, rem, and in this template I want to use colors to make it easier to see the different parts of the template, and it'll make it easier to find different parts and to troubleshoot and to modify and so forth. So for line 10, I'm going to put a rem statement that tells us what the name of the program that we're working on. So in this case I'm going to call the program modular template. So I want to change my ink color to red. So to do that, I'll go into extended mode here and press the Shift 2 key like that, and now I have red ink. And I'm going to type in the name of my program, which is modular template, and then I'll put a .bas extension on it because we're going to use this template to create basic programs, obviously. And then I'll change the ink color back to black. So I'll press Control Shift to enter extended mode, and then Shift 0 to get my black ink back, and enter. Okay, that's a good start. So now what I want to do in making my modular programming template is I want to reserve areas in the template for different parts of the program, obviously the different modules. So since every program has a main game loop that runs, I'm just going to enter a game loop at, let's say, line 1000, and I'm going to put a rem statement here, and I'm going to kind of highlight this main game loop section by using some graphics characters. So I'll go into graphics mode here by pressing Shift 9, and then I'll just press the number 3 key to get some of these flat kind of lines on the screen, and I'll type a space, and then I'll write game loop. And since we're in graphics mode, the characters automatically come up in capitals mode, so that's fine. And now I'll press the 3 again to get some more of those lines and exit graphics mode now. And there's my main game loop starting at line 1000. And I'm going to reserve the lines from 1000 to lines 4999 for my main game loop. So just in case there's any problem with my program where it doesn't terminate properly or it tries to run over the end of the main game loop, I'm just going to enter a stop statement now at line 4999. Stop. So that will stop the program from running just in case, like I said, it doesn't terminate properly from the code that we've entered, or it tries to overrun the end of the game loop for some reason. Okay, so now we need some place to reserve our subroutines, and I'm going to call these subroutines sub. So let's say the subroutines start at line 5100 for our first one, for example. And of course you can start your subroutines wherever you like, but I'm just using this as an example. So let's say 5100 will be where my first subroutine starts, and I'll put a rem statement, and I'm going to call this subroutine just sub1, just like that. And I'll enter some more of these, so I'll just bring this down and edit it. Line 5200 will be sub2, line 5300 will be sub3, and so on. You can have as many subroutines as you like, obviously, so I'm just going to start off with 3 for now. And then what I want to do now is enter some return commands, since obviously every subroutine has to return at some point. I'm just going to enter those in now so they're already in the subroutines to begin with. So I'll enter the first one at line 5199, return, and then 5299, return, and 5399, return. Okay, there, so now we have 3 subroutine sections reserved with their return statements already entered. And now I want to create another section where the program gets set up. So all programs usually have a setup section where all the variables get initialized and so forth. So let's go ahead and reserve a place for that now. So I'll put that at line 8000 rem, and I'll just call this setup, just like that. And then this routine also needs to return, and I'll give this until line, let's say 8999, and then I'll put a return command there as well. And now often games also have a section for storing data that gets read into the program using read statements, and since that's a common section, I'll make a place for that now as well, and I'll put that at line 9000 rem. And now I want some more graphics characters, so I'll go back into graphics mode and press the 3 key a few times, put a space, and then type the word data, and then the 3 key again, and then exit graphics mode and enter. Okay, there, so now we have a very bare bones starting to our template that is going to be used for creating modular programs, and we're going to add a bit more information to it now just to make it a bit more complete and more functional. Now I mentioned I wanted to use colors to highlight the different parts of this template, so I'm going to enter those now. So I'm going to start by coloring these subroutines. So I'm going to just bring down this rem statement, and I'll go just before the name of the subroutine, and I'll go into extended mode, and I'm going to press 1. Since this subroutine is called 1, I'm going to use color number 1 for the paper, which is blue. And so the subroutine now has changed to blue. And now if I go to the end of the subroutine, I'll go back into extended mode and press 7, which will give us our white paper back again, because we don't want the paper to be blue for the entire template. So if I press 7 now, we get our white paper back. And I'm going to do the same thing for the other subroutines that I've set up, or the rem statements for the other subroutines that I've set up. So sub 2, I'll go into extended mode and press 2 to give us red paper, and then go to the end and then paper 7 to get our white paper back, and then down to sub 3. Extended mode 3 gives us magenta paper, and back to white at the end there. So now we have some color coding for our 3 subroutines. And let's go down to our setup subroutine, and we don't want to forget that. But this one, I want to give this one a black color. So the way I'm going to do this is I'm just going to go into inverse mode by pressing Shift 4, just like that, to turn it inverse, or white printing on black paper. And then I'll go back to the end and press Shift 3 to go back into regular mode, or non-inverse mode, and then I'll press Enter. So now our subroutines are all easily identifiable by their colors. And now we're going to do something that I think you don't normally see in basic programs, particularly in Sinclair Spectrum basic programs, mainly due to, I think, the shortage of memory that was in a Spectrum computer. But I want to add a little more functionality to this template so that it makes it much easier for us to use, and I'll show you why in a moment. So the first thing I want to do is add some variables to this setup section, because this setup section is where we're going to be setting things up, including declaring variables. So let's set up some variables that keep track of where our subroutines are located. So I'm going to enter line, let's say 8100, and I'm going to call these variables the same name as the name of the subroutines. So I'll say let sub1 equal the line number where subroutine 1 starts, which is 5100. And I'll do the same for the other subroutines. So I'll just edit this line and say line 8200, let sub2 equal 5200. Line 8300 will say let sub3 equal 5300. And now I also want to enter a couple more variables to keep track of other areas of the program. And I'm going to enter these actually before these subroutines. So I'll enter line 8010 let, and now I want a variable that's going to tell me where the main game loop is, and I'm just going to call this one game. So I'll say let game equal the line number where the game subroutine is, which is line 1000 in this case. And I also want a variable to keep track of where the setup subroutine is. So I'll enter line 8020 let setup equal 8000. And so now we have our subroutine set up, our main game loop set up, our setup subroutine set up, and a section for entering our data as well. Why is this so useful for us to declare all these variables like this? One reason is when we're calling our subroutine, instead of having to remember what line number that subroutine starts at, we can just use the name of the subroutine, which is also coincidentally, or not coincidentally, the name of the variable that we've assigned to it. So let's say, for example, we're creating our game now, and we want to start entering some program lines. I want to have as little code as possible in the main game loop, whereas I want most of the code to be broken down into these small modular subroutines, because that's the whole point of this exercise, right? So our game loop starts at line 1000, and I'm going to enter line 1100. And let's say our game loop, first of all, wants to call subroutine number 1. So I'm going to enter go sub 1. So I don't even have to remember what line number this subroutine starts at. And of course you can rename the subroutines whatever name you like. So you can have the name of the subroutine matching the variable that stores the line number where that subroutine begins. And I'm just going to add some more lines of code to our main game loop now. So I'll copy this line here and say line 1200 go sub 2, and line 1300 go sub 3. So now we can see if our code actually calls these subroutines and returns from them automatically using this template that we've set up. But before we call any of the subroutines, we first need to call the setup subroutine to set up all the variables and so forth. But the variable that keeps track of where the setup subroutine is doesn't get declared until the setup subroutine runs, obviously. So we're going to need to call that one manually. So I'm going to enter line 1010, and it's going to call the setup subroutine, but it's going to have to call it using its number. So I'm going to say go sub 8000 and enter. And now the main game loop will first of all call the setup subroutine, which sets up the variables, and then it will call the other subroutines one by one. So if we execute the program now by typing run, we can see that it has reached our stop statement at line 4999, but we can't actually tell if it's actually called the other subroutines. So now I want to show you another feature which is useful for us, which is why we've set up all these variables to keep track of where these subroutines are, because not only can the program now easily call these subroutines using go-sub commands within the program itself, but now we can also list the parts of the program that contain these subroutines by using their variable names. For example, if I want to list our program where the main game loop starts, all I have to do is type list game, and then it starts my listing from the main game loop. And similarly, I could say list sub1, and it shows the listing starting at the subroutine number 1, or I could even list setup, and then I can easily see the listing starting from where my setup begins. So this way it will make it, I think, a lot easier and a lot faster for us to actually find all the different subroutines for when we want to make changes or additions to these different parts of our program. So I think that will be really handy and a really cool feature to have. So now we have essentially our completed basic template for our modular program. But we could even add some more features to this if we wanted to, depending on what type of functionality you wanted to have, which is one reason I use these colors. So for example, if we wanted to know whenever a certain subroutine is running, we could change the border color to match the color that we've used to highlight the name of the subroutine. So in this case, since subroutine 1, for example, is highlighted using the blue color, at let's say line 5101, I could immediately change the border color to blue, like that. And I could do the same for the other subroutines. If I bring this line down and edit it to 5201, border color 2, and then 5301, border color 3, and so forth. And obviously as our program grows and we end up with more than 7 subroutines, because there are only 7 different colors available to us, then we'll have to start reusing the colors if we want to use this technique to keep track of what subroutine is running. But at least it's a starting point, so it will work fine like this for shorter programs, or we can maybe use this functionality for longer programs as well. And actually I'm going to just change the border color in the setup subroutine as well. And this one I've used the color black, so I'm going to set this one as a color black, which is 0. So now when I'm calling these other subroutines, since I know those subroutines are going to be changing the border color, I want the border color to change back to white once it goes back to the main game loop. So I'm going to do that by modifying these go-sub statements, and I'm just going to add a border statement at the end of them. So I'll go to the end here and put a colon, and I'll say border 7, which is white. Because the main game loop always uses a white border, so I'm going to always change it back to white. And I'll just do this for the rest of the lines that call these subroutines in this main game loop as well. So I'll put border 7 here, and then this one I'll say border 7 as well. And then finally, after subroutine 3 gets called, I'll change the border back to white as well, which is color 7. Okay, so now whenever a subroutine gets called, the border will change color, and then it will come back to the main game loop and the border color will change back to white. So this should give us an indication of which subroutine is running at any one time, if we think that's a handy thing to have. At least we have that functionality we can use if we want to. So if we run it now, however, let's see what happens. So it runs so quickly, obviously we can't tell what border color is actually being shown because it goes back to the main game loop so quickly. So just for our testing purposes, why don't we add some pause statements before these subroutines return back to the main game loop. So I'll just do that by editing these return statements and putting a pause statement at the beginning. You could use the pause 0 function, which will have the computer pause indefinitely, but I'm going to use pause 4E4 because that's the way I learned it when I was younger. In the books that I was reading about BASIC, it used 4E4 because it sounds like forever, as you're probably already aware. So I think it's kind of cute, and I'm just going to use pause forever instead of pause 0. And then I'll put a colon here before it returns. And I'll just copy this to the end of the other subroutines as well. So line 5299, line 5399, and we don't want to forget the setup subroutine, which is going to end at line 8999. Is that right? So we can check that by listing, here we go, our setup subroutine, and yeah, that looks right. So now when we call these subroutines, or rather when the program calls the subroutines, they should pause before returning back to the main game loop. So let's give that a try. We'll say run, and now it's white, which means it should be in the main game loop. And let's just stop our program here by breaking into it and seeing why it's pausing there. So again, I'm going to list the main game subroutine by just, or the main game loop, by saying list game. And why is it pausing here? So the first line says go sub 8000, where it goes to 8000 and it sets up the variables, and then it pauses forever. Because I didn't change the border color in the setup subroutine, so I better do that now. I'll enter, well, let's take a look at the setup subroutine by listing it, list setup, and now we can enter a line, let's say line 8001, border 0, which is black. But I also want the program to pause now when it gets back into the main game loop before it calls these other subroutines. So if I list the game loop by saying list game, and these variables only obviously get initialized once the setup subroutine runs. So if you just type in this program and then try typing list game or list sub1, obviously it's not going to work because the variables haven't been defined yet. But once we run the program the first time and all the variables get defined, then we can use this little trick to list these parts of the program for us. So in our main game loop, I'm just going to add some pause statements here so that we can tell when we're in the main game loop. So let me enter one before it calls any other subroutines. So I'll just bring these statements back down and I'll enter pause statements, pause forever, and with this one as well, pause forever. And I'm just bringing down all these go sub statements and adding pause forever in front of them. And finally this one, pause forever, like that. And so now it should pause when it's in any of the subroutines and also when it's in the main game loop. Let's give that a try. So we'll run, and now it's in the main game loop because the border is white, and we press a key and it's black now, which means it's in the setup subroutine, and we press a key back to the main game loop, and then in subroutine 1, which is border color 1, which is blue, back to the main game loop, border color 2, which is red, so it's in subroutine 2, back to the main game loop, and now it's in the setup subroutine, which has a black border. And why is it in the setup subroutine? Let's take a look. So I'll list game and setup. So subroutine 3, you can see down here, if we list sub 3, we can see that I've set the border color to 0 for some reason, so it needs to be color number 3, so I'm just going to change that to 3, so the border will turn to magenta when subroutine 3 executes, and now it should work properly. But just to make it more descriptive, why don't we put some text here in these subroutines to tell us where our program actually is. Now, I wouldn't normally use text indicators in a program that we're creating, but just for this example, I think it would be kind of cool to take a look at. So at the beginning of each subroutine, I'm going to add a print statement now. So I'll just modify this line that changes the border color by bringing it down. And at the beginning of it, I'll just add a print statement to print what subroutine we're in. So I'll say print, and in this case, it's going to be sub 1, and then a colon. And I'll bring down the next one and do the same thing. Print sub 2. Print sub 3. And we'll do the same thing for the setup subroutine. bring this down and say print setup. And we could even do the same thing for the main game loop. So let's go to the main game loop by saying list game. And where do we want to actually print when we're in the main game loop? So I think we're going to need to print this in a few different places, because every time it calls a subroutine and it comes back to the main game loop, we want to indicate that it's actually returned. So again, why don't we modify whatever lines change the border color, and we can do that right here by entering our print command right at the end of it. So I'll put a colon at the end and say print game. And I'll do that for all of them. Print game. And finally, print game. Oh, and there's one more right here. After it calls subroutine 3, it comes back, and I'll say print game as well. And now every time it comes back to the main game subroutine, it's going to print the word game, so we can see it's back in the main game loop. And if I just take a look at this main game loop again, we want to have, I think, one more print statement when the game loop first runs. So I'll put at line 1001 print game, just like that. So now we've added a lot of extra bits to our template that don't need to be there when we're actually using this template to create a real program, but this will give us an indication of how the program is actually working. So let's run it now and take a look. So run, and now we can see we're in the main game loop with a white border, and I press a key, and now we're in the setup subroutine with a black border, another key, and that brings us back to the main game loop with a white border, subroutine 1, blue border, main game loop, subroutine 2, red border, main game loop, subroutine 3, purple border or magenta border, and back to the main game loop where the program stops. Now there's a couple more little pieces we could add to this if we wanted to that will increase its functionality a bit more, and of course it's up to you whatever functionality you want to add, which makes it so useful for us to have our program divided up into these little modules now, because we can add these bits and pieces to modify the functionality the way we want, and it's very easy to do. As you can see, we can list the program at whatever section we want the listing to show up as. We can list the modules individually, and so far it's making our development, I think, a lot easier. So one thing I want to look at now is what happens when you have a situation where a subroutine is being called from within another subroutine. So we can do that in this case by changing the border color back to its original color from within the subroutine, just as we did with the main game loop. We changed the border color back to its original color, and we can do the same within our subroutines. So let's say subroutine 2, for example, calls the setup subroutine for some reason. So we could add a line of code in here. Let's say line 5210 go sub, and now we can use the name of the subroutine. So see how easy it is. We don't even have to remember what line numbers the subroutines start at. So we can say go sub setup, and since we're calling a subroutine from within another subroutine, I'm going to put another statement here. So when the subroutine returns, it's going to change the border color back to what it should be for this subroutine. Because remember, when it calls setup, the setup subroutine is going to change the border color to black. So when it returns, it's going to come back here where I'll put a statement border. And since this is subroutine 2, which has a red color border, which is color number 2, I'll say border 2 and enter. And that's all we need to do. So now when our subroutine 2 calls the setup subroutine, it will automatically change the border color back to red when it returns. But let's do one last thing first, is put a pause statement before subroutine 2 calls the setup subroutine again. So I'm just going to bring this line back down, and I'll put pause forever and then a colon. So now before subroutine 2 calls our setup subroutine again, it will pause. So let's enter that, and we'll run the program now to see what it looks like. So now it's in the main game subroutine with a white border, and I press a key and it goes into the setup subroutine with a black border. Press the key again, back to the main game subroutine with a white border. Now it's in subroutine 1 with the blue border, which is color number 1. Back to the main game subroutine with a border color white. Into subroutine 2 now with a border color red. And now it goes to the setup subroutine because subroutine 2 called the setup subroutine. And now when I press a key, it should return back to subroutine number 2 and the border should go back to red, which it does. And now if I press a key again, it goes back to the main game loop and then again to subroutine 3 with the magenta border. And now finally it goes back to the main game loop where it stops. So that's pretty cool. So now I think we can see the advantages of creating our program in a modular fashion by using modular programming. It makes it, I think, really easy to create the program and to test out the different modules individually. And also, as we just saw, it's very easy to troubleshoot a program that's been created this way. So there we go. If you think this would be a useful technique for you, feel free to use it. I think it makes it a lot easier for us to create a basic program using modular programming techniques. So there we go, that's it for today, and I want to thank you for watching. And just as a little treat for those of you who are Patreon subscribers at a level that give access to the private Facebook group, I've actually uploaded a PDF copy of the book that I mentioned earlier, which is The Spectrum Programmer. Feel free to check it out if you think it's something you might be interested in. Otherwise, of course, you're always welcome to follow along with this free content. I'm not doing this for money. I'm doing it for the love of creating retro video games, as I think, which is why we all do this. So, thanks again for watching, and I hope you're having a great day, and we'll see you next time.